Hey, welcome to the third session. Hope you guys have a little bit of energy left before we take a lunch break. And welcome to everyone out on the intertubes. Hi, Mom. My name is Jan Markiewicz, or JK. I'm a PM on the Windows Core Experience team. And I've been working on designing for touch, mouse, and keyboard across the system and all our apps as well. And today, I'm going to talk about how you can make a great touch app, but also make it work really well with mouse and keyboard. So we'll be covering a couple of things today. I'll spend a little time in the beginning to talk about the general philosophy about input for Windows 8. And then I'll spend a lot of time talking about touch and the touch language and some patterns you can use to make your apps really great. And then at the end, we'll talk about mouse and keyboard as well. So before we start with that, I want to tell a little story. So my wife and I, we recently bought a new house. And when you buy a new house, you often buy new furniture. So we went out to buy new furniture, and one of the things we needed was a coffee table for our living room. So now this is kind of a nice basic coffee table, kind of great general purpose. But since we moved from Norway to the US about 6 years ago, I guess we've adapted to the American lifestyle, and we really enjoy watching our favorite shows while eating dinner once in a while. So using this table to eat and watch TV isn't that great, because you'll be just like all scrunched over, trying to eat and watch the show, and it doesn't quite work, right? So what we could do is we can get this table, which is a nice tall table. It would be great for watching TV and eating. But on the other hand, it will kind of suck at general purpose living room usage. Like, you don't want a huge table in the middle of your living room. So this was, of course, this kind of aligns with what Bill Buxton always says, where everything is best for something and worse for something else. So in this case, we have one table that's awesome for general purpose living room on the left, and then we have one table that's awesome for eating. But they're good at different things. So this was a horrible dilemma, of course. And you might be wondering how we solved it. Well, we got this table. And it's kind of a low table. I feel like it's nice for general purpose stuff. And you can put your coffee cup, works really well. But now if I want to eat and watch TV, what do? Well, with just a simple motion on my hand, it actually transitions and turns into a good table for eating and watching TV. And I can easily just push the plate back down, and it's great for general purpose living room again. So there's something important about the way this table works. I don't know if anyone noticed it. Any ideas? I'll reveal it then. I didn't have to remove anything from the table to do that transition. It's a very fluid, smooth transition, right? So I have a table that's great for general purpose living room. I have a table that's great for eating, and I can fluidly transition between the two. I don't have to remove everything from the table, like build a little project thing to make it tall and then put stuff back on again. I can just easily transition between it. And you might be wondering why I'm talking so much about my coffee table. And it's really because the same thing applies to input. Everything is best for something and worst for something else. Now, we love touch. We think touch is the future, touch is great. But we also think that mouse is great. And we think that keyboard is great. They're just great at different things. So it's hard to beat the direct interaction with content that you get from touch. But it's also hard to beat the precision you get from mouse and the ability to interact with your content from a distance. And it's hard to beat the text input efficiency of a keyboard and shortcut commanding. But if we combine the benefits of all of them, and just like the coffee table, we have fluid transitions where you can really smoothly, based on your context, based on your task, use whatever input is best, we can make this the best system ever. So you really have to think about how we make this work together, right? So we want to make optimized interactions for each input, because if we just go to the lowest common denominator, we're not really leveraging each input. So how do we do that? Well, so we'll have, this is one example of how we do it. So we have touch, mouse, and keyboard. And in most cases, we have a common action. So in this example, it's to select an item. So what we do is we have a common action, but we actually have optimized invocation for each input method. So for touch, I use the swipe gesture. With mouse, it's not that great to swipe down and click and drag objects all the time, but we have an extra button, which is awesome. It's the right button. So we leverage the right button to select. And for keyboard, we use the space bar. And now I can easily arrow around and like use my thumb to hit this big space bar in the middle. So as this works on the start screen, with touch, I just swipe down to select. With mouse, I just right-click to select. And with keyboard, I just arrow around and press the space bar. So each input method has optimized invocation, but they end up doing the same action. So this is a principle we use across the system. And it really lets us leverage the benefits of all the different input methods. And it lets users fluidly switch between whatever input method makes the most sense. So however, when you do build your app, you kind of have to focus on something. You can't just go off and try to do everything at once. So something we've learned is that it's really important to design for touch first. So there's a couple of reasons for that. Just the immediacy and the direct interaction with content, and the fact that your body makes such a big difference to how you use your app is very special for touch. Like the way you hold your device is going to affect the layout of the app, and the way your fingers work is going to dictate things like target sizes. So if you design for touch first, it's actually pretty easy to do some optimizations for mouse and keyboard later to make it really great for mouse and keyboard as well. When you build your app, make sure that everything is possible to do with these three input methods. So even though there'll be a lot of touch devices out there, not all machines will be touch. Some will be touch only, some might be laptops with mouse and keyboard only. And you really want to get the broadest reach for your app and make sure that everybody can use it. So make sure all actions are available for touch, mouse, and keyboard. And then the good news is that all this fancy behavior I talked about is actually built into our common controls. So if you do use our common controls, like our list view, you get the behavior I just demoed on the start screen for free. All you say is, I want my list view to have selectable items, and it does the right thing for all the three different input methods. So that was quickly a little bit about our philosophy about input. Now let's dig a little deeper into touch. So I want to take a little step back first and talk about mouse. So mouse has been around for a long time. And mouse actually has a language when you think about it. When you see any graphical user interface out there, you pretty much know how it works because they all work in a similar way. When you move your cursor around, you know you're pointing at something. And you'll see scroll bars, and you know that's how you move content around. So it really has a language that's been refined for more than 25 years. And it's really useful because now you know how to use all these systems. And it's really in a similar way to how we communicate with people. If I know a language and the person I'm talking to knows the same language, I can get them to do stuff for me. I can communicate. And now if I have 3 friends and we all speak the same language, the same thing applies. We all can communicate. And now if you have a bunch of people, the same thing applies. So I'm not really talking about people here. I'm really talking about apps and touch interactions. So the first person you saw, that's Windows. So if you know how Windows works as a user, and the other apps, just like these other people, work the same way, you can communicate with all the apps. You don't have to learn anything new. You can say the same thing, and they all react the same way. So this is why we put a lot of work into making a touch language. Similar to mouse, which has kind of happened over time, we think it was about time that touch had a solidly defined language that defines common interactions we use both in Windows, but also across applications. So if you use the same interactions as we do in Windows, which users will learn, and they'll have to use it to use the system, your users automatically know how to use your app. It'll be more intuitive, it'll be more enjoyable. They don't feel like they have to relearn every time they go into a different app. So it's basically you learn the language once, and then users are going to expect it. And we've done tons of usability studies here where we would make basically fake apps and apply the same interactions. And it was really interesting to see how people learn to semantically zoom one place, and they just expect it to work all the other places. And they would be really disappointed if it didn't. And this is really about confidence, because once people learn these interactions, they will kind of expect it to work other places and work the same way. And if it does, they'll feel good and confident. If not, they'll be frustrated and feel like they just need to relearn and remember. So it's really better to get their story here if we can all use the same touch language. And then if you use the touch language, you don't really have to worry about figuring out certain interactions. You can actually focus on what value add your app gives. So you can focus on your content and how you should do that, and just leverage touch language, and you'll get all that for free. And that's similar to, like I mentioned for general input stuff, these interactions are actually built into our controls. We have controls that make this really easy to build. So this is the touch language. It's very easy. A few interactions that let you do pretty much all you need to do. We have press and hold to learn. And I'll give you guys a quick run through. Just quickly mention these. We have tap for primary action and slide to pan, as you kind of expect. We have swipe to select, which is a little new, so I'll give you guys a demo. We have pinch and stretch to zoom or use semantic zoom. And turn to rotate. And then we have the edges for system commands and for app commands. So let me start out on the start screen here. So as you expect, when I put my finger down, I can pan around. The content moves when I slide. If I want to do a primary action on one of these tiles, which is to launch it, all I have to do is tap. So tap, and it launches, right? Kind of as you expect, of course. So I can use the right edge to pull in the charms window, and then tap as the primary action on the start menu, start button. So now I want to do something a little more exciting. I want to actually command on one of these objects. I want to make my desktop tile bigger. And let's assume I've never used the system before, and I want to kind of learn how it works. Well, I said we use hold for learning. And the great thing about using hold for learning is that even though it's timed, once I've learned it once, I never have to be slow again. I'll show you this. So if I press and hold on the desktop tile, there's this little animation. And we call that a self-revealing gesture. So let me show you that again. So it's just a little hint to the user that you have to do something else to select this item. And it's really a hint that you have to drag it down. So once I've seen that, I'll actually try to drag down, and I'm able to select. So the self-revealing gesture we show on hold teaches me how to select. And once I've done it once, I don't have to wait anymore. I can be super fast. I can select all my tiles really quickly. And I'll be fast for the rest of my life. I was slow the one time I learned it, and now I'm really fast. And then, as you also probably noticed, at the bottom, we do show the commands in the app bar automatically when you select. And this gives us this fast and fluid commanding option, where I can now just quickly remove the selection, and I can select the desktop tile and make it larger. I can make it smaller. I can do all this really fast and fluid. I'll talk a little bit more about details in the swipe thing in a second. I'll show you another example here. So this is the mail app. So swipe to select just works orthogonally to the scrolling direction. So on the start screen, we scroll horizontally, so I swipe up or down. In the mail list, I scroll up and down, so I swipe to the left or to the right. So I can do whatever feels right at the moment, and it's the same interaction. So again, once the user has learned this language of swiping, they can use it in all our apps. And again, the menu for commands show up at the bottom as soon as I select something. An extension of the swipe interaction is that you can actually swipe down, and if you keep pulling, the item actually comes loose, and now you can rearrange. And I can put it here if I want. And the key thing about all of these interactions is that they're not timed. So like swipe down is not timed. I can learn to do it really fast. Same thing with this drag down to rearrange. Once I've learned it now, I can be really fast. I don't have to press and hold and wait for something to happen, get into a special state, get out of the state. Just really fast and fluid, efficient, moving stuff around. And like you can drag down to get it loose, you can drag up to get it loose, and same thing with selection. You can drag up to select or down to select. So that's a quick demo of swipe there. Let's go into this photo library app. So kind of as you expect, you move content around with direct manipulation. You tap to do the primary action, which is to look at this photo. And now I can just stretch my fingers or pinch them to zoom around through content. And notice how it's always stuck to my finger. So I'm in full control here, even if I translate while I'm pinching. We don't go into this special mode where you're only pinching. You're still in full control. So that's optical zoom. But we also have semantic zoom, which is similar in the way I invoke it. But instead of just showing an optical representation, we can imagine on the right here all these icons with the text would just be super tiny, and that's not very useful. So instead, we actually replace them with something more useful, which is this big iconic representation. So even though the tiles are small, you can actually see what it is. And I can actually recognize that this is Word, and I can tap to get to it. And similarly, I can pinch out, I can stretch to go back in. And when I'm in this view, I can actually still swipe to select. But since I'm now looking at groups, I'm selecting the whole group as opposed to a single tile. We have, I showed swiping on the right side for the charms. You can also swipe at the bottom to pull up the app bar. You've seen that in John's talk as well. And then if I want to switch apps, I can just pull in from the left edge, and I'll go through my apps, and I can go back to my presentation. So that's a very quick overview of the interactions. Like I said, very easy. Once users learn it once, they kind of expect it to work everywhere. So please work with us. Make sure we have a great touch language in Windows 8 and for all the Windows 8 apps. There's a lot of interesting things about touch because we're interacting directly with the screen. For example, our human anatomy, the ergonomics, how we hold the device, it all affects the interactions that are good and bad for touch. And we've taken all that into consideration for our touch language. So for example, the swipe interaction is great because it's really easy to just flick down with my finger, right? So if you use the touch language, you get this for free. We do have a talk that Kai and I did at the Build conference, which is called Designing Metro-Style Apps That Are Touch Optimized. So I really encourage you to look at that talk. And it goes into more detail about the actual, how we came up with the touch language and more details behind that, and a little bit more about anatomy and ergonomics. So if you're interested in that, put a quick link up at bit.ly build touch optimized. But I want to mention a couple of key important things to think about for those that haven't done a lot of touch design before. And if you're coming from building mouse apps, these are really important. And these aren't necessarily good or bad, they're just different. So the first thing to realize is that touch is inherently sloppy when you compare it to mouse. Mouse is a tool designed to be very precise. With touch, our joints and everything affects how we do stuff. So when I'm panning around, it's not going to be a perfectly straight line. But if you look at the start screen, even though my contact moves up and down a little bit as I'm doing this, the start screen looks nice and it's on rails. And similarly, once I drag a tile down to select it, I can be a little sloppy. It doesn't randomly do something else. So that's all built into the system, and we've taken that into account. And that's the thing, you just need to take this into account. It's not bad, it's just the way touch is. Touch is a two-state system. So for mouse, we have the great hover state, so we can either move our cursor around, we can hover, we can see what we're doing before we're committing. With touch, all the system knows is nothing's happening or like full interaction. Like I'm touching. There's no, like I'm already committing. So again, this is really good for some things. For example, it makes sliding really awesome. To move an object around, I don't have to press a separate button to engage. As soon as I touch the screen, I'm automatically engaging. And that's why sliding and panning around is so great with touch, but kind of tricky with mouse because you have to like move your cursor as you click and release at the right time during motion. So it's just something that's different. And sliding also has a lot of inherent information in it. So for example, on the start screen, you can slide left and right to pan or slide up and down to select. And we can actually leverage the direction to do something useful there. The other cool thing about touch is that we support multiple simultaneous inputs. So I really encourage everyone to think outside the box here, get a little bit away from the mouse paradigm of single cursor, and think about how you can leverage multi-simultaneous input. So as one example here that we've implemented is that once you drag a tile out, I can actually use my second finger to pan around. If I want to put this at the end, I can do that really easily. Or I can actually pull it out, and now I can zoom out with my second finger and put it at the front. So you can't do that with mouse, but you can do it with touch. So you really have to think about how touch is different when you design your apps. So I'm going to talk about some of the touch patterns that you all can leverage in your apps, and these kind of best practices, ways to align. These are things we follow in Windows, and we hope that you will for your apps as well. So I'll start by talking about direct manipulation. And all the stuff I've showed you so far is direct manipulation. What it simply means is that content sticks to my finger, and it follows my finger immediately. So there's immediate feedback as soon as I touch down. I'll see the feedback of the item following my finger. There's no invisible thresholds. It's really important to tell the user what's going on. And then we also have our interactions reversible. So let me show you with select here. So as I drag down, you can see the item immediately follows my finger. There's visual feedback with the little check mark underneath it. And once I drag far enough, you can actually see, show a tile that has a little more contrast here. There's a highlight around the tile itself, which makes it very clear that I've selected the item now. And when I lift, I commit. And I can reverse this if I don't want to do it after all. So if this is not selected, I drag down like, oh, this is some selection thing. I don't want that. I just push it back, and nothing bad happened. So this makes it really safe to explore. And that's important because that two-state thing I talked about. Because with touch, nothing's going on, or I'm fully engaging. So if I drag down now, there's no way to undo unless we have this reversibility where I could push it back. So it really gives the users a sense of confidence to explore. You can imagine swipe to select be built in more of a gestural way, where you just flick down your finger, and then suddenly the item is checkmarked. And that's not direct manipulation. That's the core difference there. We have this immediate connection to your finger. It follows your finger, and then you get feedback during the whole interaction. So what this really gives us, it gives us learnable interactions. Because now, as I'm doing this, whether I'm just playing around, I accidentally move this item, or someone's showing me, I can really understand what's going on. Because we're really upfront to the user, giving real good feedback of what's happening. And by using direct manipulation, we have another tool in our tool bucket for making great apps that focus on content instead of the Chrome, because you can actually manipulate the content directly as opposed to having buttons for scrolling or buttons for zooming. Part of direct manipulation is kind of just like in the physical world. If you're moving something with one finger and you push with two fingers, it doesn't dramatically change the interaction and does something randomly, weirdly, differently. So the same thing applies for direct manipulation. So keep your interaction such that you can allow any number of fingers, and we do that as well. So when I'm on the start screen, if it's one finger or two fingers, I can still pan this content around. I can zoom out with two fingers, or I can zoom out with like 4 fingers. So I don't have to be really careful about that. So this is, again, it goes back to the sloppiness. If I'm careful and do it with 2 fingers, that works fine. If I just happen to touch the third finger while I was doing it, we don't radically do something different. And this accounts for sloppiness in the user, or in touch interaction from the user. But it also makes it much easier to understand what's really going on, because users don't really notice if a third finger touches the screen necessarily, and if you randomly now change the color or launch the settings or something, users get confused. I mentioned timed interactions a little bit. Avoid using timed interactions, and this things like press and hold. The reason we want to avoid timed interactions, it's really, I call press and hold catch-22 of touch interactions, because it's either too fast for novice users who are just holding, or you just like to read while you're holding, and then you accidentally invoke stuff, or it's too slow, and you're an advanced user, or you just want to be efficient, and now every time you have to wait for the action when you're pressing and holding. So now if you look at the start screen, I showed you use press and hold to learn, which is good because you do it one time. You pay that cost of holding once, but once you've learned the swipe to select action, you can be fast for the rest of your life. So just want to show a little example of how you can kind of solve what typically might have been done with press and hold. So this is an example of an app, a Minesweeper style app. You tap around to reveal what's under the tile, and then you need a way to flag so that you think there's a mine there and you want to leave a flag. So you could use press and hold, but now every time you want to flag in a game that's actually based on being as fast as possible, you're slowing down the user. So that doesn't seem great. So what you could do instead is you can use a touch language. You can use swipe to select. Flagging is really just a selection. Or you can use direct manipulation, and I'll show you some examples. So I'll tap down to reveal what's under the tile. Notice how there's immediate feedback on the tile. I touch down, it highlights, shows me what's going on. I lift, shows me there's 2 mines around. And now I want to flag next to it. So I press down again, and as I drag the tile down, I reveal a flag or a selection underneath it. And when I release, I commit the selection. So now I've learned two really fast ways to both reveal under a tile as well as flag any tile. Example of using direct manipulation here. Again, you tap to reveal because that's the primary task here. If you want to flag something, you can just drag it to the place you want to flag. And notice again, it's important to pay attention to the visual feedback. I'm highlighting the place where I'll place the flag so the user knows what's going on. And when you lift, the flag is placed there. And now you could even extend this to have other commands, if you have a question mark command or whatever you want to have in your game or app. A slight variation of this goes back to thinking about multiple fingers. So in this case, what if I use multiple fingers to solve this? So I hold down on the flag thing, and it gives me some hint that I can tap around to actually place flags now. And when I tap, I'm placing a flag. And I can really quickly just tap around while holding my finger there. When I lift, it's back to normal. I just tap to reveal. So those are some examples how you can solve the Minesweeper kind of problem. This really applies to most apps. We've been reviewing a lot of apps, and these are some solutions you can apply to a lot of scenarios. There's another common solution we use a lot, and that's if you have a scenario where you have a UI element and there might not be a super clear primary task. It's like not a 90% task, you always do that thing, but there might be one that's a little more important and then a bunch of other ones. Then you could just use tap to launch a menu that lets you choose. So this is an example of the user tile, which you can't really swipe to select because it's not in the list, it's just by itself there. So instead of having tap go directly to account picture or whatever option we would choose, we just show the available options at that point. And you might think, oh, it's so much work to tap twice. As long as you use the right target sizes, it's not that much work. You'll just have 2 quick taps and you're there. This would actually be slower if you had to press and hold, because then you would have to press and hold, lift, and then go and tap again. So by using 2 taps, you can actually be pretty fast. So just quick summary of direct manipulation. So emphasis on the immediate feedback. It's really core to the whole thing. We don't have invisible thresholds. So that kind of comes out of content is following your finger. You see what's going on. As soon as something changes, show it to the user. If when you drag an object to a trash can, it's going to be deleted, change the state of something. Like make the object transparent or something to indicate to the user that something's going to happen if you lift your finger now. Keep the interactions reversible to make it safe to explore. And allow any number of fingers. Don't do these random interactions just if the user happened to have an extra finger on the screen. And keep your interactions untimed. So I showed a lot of visual feedback already with direct manipulation, but this is something I just want to highlight because in our reviews of apps, we see this all the time. And it's such a simple thing. So when you review your app, do a polish pass, as I hope you all will do. Make sure that you have immediate touchdown feedback on any interactive element. I'll show you why that's important. So here's just 2 simple buttons. I'll tap on the first one, and it's pressed. But now if I tap on the second one, it actually reacts to my press. And it's a completely different feeling. It feels confident. It feels like the system's reacting to me. It's fast and fluid. It doesn't have to be a shrink. It could be a color change or some state to indicate that you're now interacting with this element. And it's, like I said, it's very simple to do. It's also very simple to overlook. So this goes for all interactive elements. But what about non-interactive elements? How does the user know what's going on? So I'll show on the start screen here. If I press down on the mail app, you can see it kind of gives me feedback. It shrinks like that. But now, if I tap on the start text, that doesn't actually have any action. So the system will provide the right feedback in this case. So right now, I'm using these special projection visuals to make it really clear where I'm touching. But if you look on your Win8 device, you'll notice that we actually show a subtle version of this when you're using your device. So that makes it clear that, sure, I tapped on start, but it just doesn't do anything. So the user knows to not punch the screen harder. It's just that start doesn't do anything. Whilst pressing on a tile clearly does something because it gives me feedback on down. Just some quick words about targeting. Like I said, it's really important to get the right target sizes. We do have what we call smart targeting in Windows 8. So instead of making touch dumbed down to single XY coordinate, we do realize that when you're touching the screen, there's like a fleshy chunk that's in contact with the screen, right? So we use this to be smart about the interaction. So in this case, in a normal system, this might not engage the button, but in our system, we actually engage the button if it's under the geometry. But that doesn't mean that you can't get away from using the right target sizes, because your finger is still a certain size. So if your geometry is covering multiple buttons, there's not going to be any confidence in the user's ability to target that. So for target sizes, there's not a single right answer. It really depends on the accuracy you want. So what we did is we did a ton of usability research where we had people target in this game, and we looked at the error rates. And as you can see from left to right in the chart, the error rates go down vastly as the targets get bigger. And it there's kind of leveling down around 7 millimeters, and that's kind of close to the area of the finger that typically touches the screen. So that kind of makes sense. So based on this, our guidance for minimum size is 7 millimeters. And that will give you about a 1% level of missed targets. So you can go smaller, you can go bigger, but just realize what you're doing. You're making it harder to tap elements, or more dangerous if you miss target in that case. So based on this is all on MSDN, all the numbers and everything. So check out that on the design site. We have translated to pixels, so it's easy for you guys to use. But basically, the minimum target size is 40 pixels in both directions. And then really important as well is the padding, because that gives the users a lot of confidence on targeting, because now they can feel confident that they're not hitting the thing that's right next to it. If there's really low consequence, and a good example of that would be radio buttons, it might be okay to go smaller just for the cleaning up the visuals. You don't want to have the world's largest radio buttons in your app. And it's okay because the consequence is not very high. If you miss the radio button, you tap again, and you got the right one. If you go too small, though, it can be hard to ever get to the one you want. So be careful. That's why we recommend down to 30, but not lower than that. And then if you want really high confidence in the taps, you should use at least 9 millimeters or 50 pixels. One technique you can use to improve targeting a little bit is what we call scrubbing. I'll just show you a quick example here. So in this menu here, I can press down on any of them, and I can actually scrub around to the one I want. So that way I can press down and get retarget to the object I want and just lift to commit. I'm not going to shut down my computer now, but so that's basically another technique you can put in your little tool belt for making targeting easier. And the same thing applies to the charms here, where you can actually scrub between them and then commit the one you want. Semantic zoom is really a touch-first way to give the functionality of a scroll bar, is the way I think about it. So it's really a solution for jumping in content. So think about mouse. You have a scroll bar. It's awesome for jumping around. We don't want to show the scroll bar when you're using touch, because you're panning around directly on the content. We don't want to show that Chrome. So how do you jump in content? Well, we use semantic zoom. It's invoked with pinch, like I showed. And one important thing to remember with semantic zoom, we did a lot of usability testing, limited to 2 levels. And that includes the 100% view and the zoomed out view. Because as soon as you do more than that, it's not really about jumping anymore. It turns into this whole navigation thing. And what we found was that users started getting really confused. Is this really about jumping now, or is this about going completely somewhere else in my app? So I'll show some quick examples. You saw the start screen. This start screen is semantic, but it's very much similar to optical. You can kind of see content changing, but this is a bigger change as I zoom out here, and you can see it actually changes to content that's useful for this view. So I zoomed out, and I get the letters of my apps, and I get the suites of apps. So I can tap on Office, and I can quickly jump to Office. I can tap on C, and I get to the apps starting with C. And this can similarly be used in apps. And it's not limited to these kind of apps that are the big panoramas across the whole screen. You can also use it within any scroll view. So if you have, like in the Mail app, a list of mails, you can zoom out there, and you would show whatever's appropriate. For example, mails based on date. So you'll show today, yesterday, and so on. It doesn't have to be this full screen experience. It's within any list view for jumping. So this is just a quick touch checklist. It doesn't cover everything, but it does these are kind of the common mistakes we see a lot as we're reviewing, or things that people just forget because there's so many other things to think about. So make sure you use real direct manipulation for your gesture interactions, so the content always follows your fingers and gives the feedback. Have all your interactive elements provide proper touch-down feedback. Make sure you follow the size guidelines so it's easy to target, and then avoid time gestures for commanding. So let's spend the rest of the time talking about mouse, keyboard, and pen. So like I said, it's the touch-first world. Focus on touch first, but mouse and keyboard is really important. So make sure all your functionality is accessible with mouse. And if you built mouse apps before, it's pretty straightforward. It pretty much works as expected. In general, interactions are similar to Win 7. You left-click to activate something, and you right-click to get to commands. Again, with mouse, you still have to think about the right interaction feedback. So let's talk about the feedback. It's very similar to with touch. Make sure interactive elements show hover feedback in this case, and also down feedback. But when you're hovering around with mouse, that's kind of a way to see, is this something I can click on to do something or not? So make sure that you show appropriate hover feedback, whether it's a little highlight or color change. You can use tooltips, but we do recommend that you be a little careful. We don't want tooltips to show up everywhere as you're moving your mouse around. It's really only when it's absolutely necessary. So if you have cut off text or you need additional explanation. You don't need a tooltip on your delete button because it says delete under it. And then for cursors, the main thing to know here is you're pretty much always going to want to use the standard arrow cursor. Don't use the pointing hand link selector cursor in your apps. That's a browser metaphor that we use there. And then for text selection, there's the I-beam. And then for moving and resizing objects, what you expect. And if you do have app areas where you can drag content around, then you can use the grabby hand. So again, it's pretty much what you expect. Mouse has been developed for 25 plus years. We think it's a pretty good system, so we kind of want to align to it and leverage the knowledge people have about mouse already. So so mouse interactions, hover to learn, left click for primary action, right click for app commands. And there's a subtlety here where you can right click on the list item to select it. But it's really all about commanding. Let me show you. So I'm on the start screen again. I can right click to see the general app commands, or in this case, it's just a way to switch the app list, and I can right click again to toggle it. But now if I right click on an element, I select it. But when I select, we also show commands automatically. So now on the left side, we have the contextual commands to this object, but on the right side, we still have the app generic commands. So now I don't have to think about where I right click if I want to go to all apps. I can do it on the white space, I can do it on any tile, it doesn't really matter. So that's really important. When you right click, make sure that the commands show up and avoid any dead zones where they don't show up. And that's basically by letting right click show the app bar. And whether it's selecting an object, then it just shows more options or not. So it's pretty straightforward. As you expect, scroll wheel should work. And then for zooming, we use UI buttons for that. So you could use, I can use scroll wheel to scroll around, and I can use control scroll wheel as you expect to zoom in and out. But we also have a UI affordance in the corner here. And when I use touch, none of this is visible. But when I switch to mouse, it actually appears, and I have a nice mouse affordance to quickly zoom out and zoom back in. And I can use the scroll wheel to scroll over. If I have my Photos app again, similarly, I can use control to zoom in or out, or use the control scroll wheel, or use the UI buttons that appear just for mouse. So again, when I use touch, those will fade away. Looks like there's a little bit, there you go. So they'll fade away. So that's kind of a general pattern we use for direct manipulation in apps, a way to translate direct manipulation to mouse-specific actions. So when you see mouse move, you can show UI elements are specific to mouse, but as soon as you use touch or after a timeout, they disappear. So in my Photos app here, for touch, I'll just flip around between these, and we don't have to show UI. But as soon as I move my mouse, we show these flipper controls so I can quickly do this with mouse. And you can imagine this will be really lame to have to drag with the mouse every time to go between photos. So we show a mouse-optimized way of going through photos instead. For scroll wheel handling, if you're using our common controls, you don't really have to worry much about it. But another thing to check in your app, if you scroll standard scroll wheel that's just vertical, it should try to scroll vertically. But if there is no vertical scrolling and there is horizontal, it should map to that instead. Because we want things, we have a lot of apps that scroll horizontally, so we want the scroll wheel to be useful here as well. And then if you have one of the fancy mice that actually has a horizontal scroll wheel, then that should just always try to scroll horizontally as well. So like I mentioned, control scroll wheel can be used for zooming as you expect from earlier as well. Just a note on this is that if you make sure that your app works properly with scroll wheels, it will also work great for the modern touchpad. So those are the new touchpads you'll see in the Ultrabooks, where you can use 2 fingers to pan, and you can actually pinch on the trackpad itself. This leverages the scroll wheel event. So make sure your app actually works with the scroll wheel properly, because then it will work with the modern trackpad. Just a quick checklist. Again, this is not all you need to do, but these are kind of the things we've seen a lot of people just miss. So once you do, when you're ready to do a polished review of your app, take a look at these. Make sure interactive elements provide the proper hover feedback, and avoid the link select cursor. Use just a normal arrow on interactive elements. Ensure users can confidently right-click anywhere in your app to get to app commands. And then only show tooltips if absolutely necessary. So keyboard is great for text input, but it's also great for navigating the system. And we have a lot of enthusiast users who just love to use the keyboard. Even they might be typing and then they quickly want to do commanding, or it's more handy to use the keyboard. And I use the keyboard all the time. I've used it many times during this presentation, just pressing the Windows key to go to the start screen, right? So make sure that keyboard works great in your app, so that you can actually have these enthusiast users feel like your app is great for them as well. So there's 2 really important things here. One is navigation. Make sure that the default focus is set on the main content. So when I go to the start screen, I kind of expect to be able to move directly here on the tiles, not that focus is somewhere up here like in the user tile in the top right corner. I actually want to use this content. That's the main scenario. And similarly, in the photo app, I expect the default focus to be on the photo, so I can quickly just arrow around and navigate the content. And look at your tab and arrow navigation and make sure it's logical. So tab is used to go through between big groups, so you can quickly jump around. And then the arrow keys should move within that content. So as you saw on the start screen, arrows quickly move up and down, left and right in the actual grid. And then you can use tab to actually move out of the grid into other content on the screen. And there's a whole bunch of shortcuts that a lot of users expect to work. I have an appendix after this at the end of this deck, and we can share more of this. It's a long list of shortcuts, so look at those and make sure you apply them in your app. If you want a way to teach how to use the shortcuts and you have tooltips for certain commands, you can put a little hint in there to show how to do this quicker with a shortcut. But don't add a tooltip just to show it, but if you have a tooltip, you can also provide that guidance there. Basic interactions, as you kind of expect, are around to navigate, spacebar on an item to select it, enter for the primary action, and then we have shortcut keys for all the system commands like the charms. So again, a quick list. The things are easy to miss in the hurry of building your app. Make sure initial focus is set on the main content. Make sure that your tab order and keyboard arrow order is logical. And avoid focus rectangles from hanging around unless you're actually using the keyboard. If you're clicking with mouse or using touch, there should be no focus rect on the screen. It's only when you're currently using a keyboard. So a quick word about Pen. Pen is really cool, and we think it's a great additional tool to what I talked about. So when I said mouse, touch, and keyboard should all have all functionality available, Pen is a little different. When you have a pen, you can assume that it's a touch machine, and touch is already great for navigation and doing everything. So think about cool ways you can use Pen to add additional value. Maybe it immediately inks. You don't have to do any special mode or anything. You can navigate with touch and then just ink with your pen immediately. And if you don't do anything with Pen, it will still work, but it will work like a mouse. That's kind of the fallback option. So think about creative, cool things you can do with Pen. So just a very quick summary. Think about touch, mouse, and keyboard, and Pen when you're designing your app. Design touch first, but make sure that mouse and keyboard are all great. And we really want to optimize for each input method. Use the touch language in your app to make it more intuitive and enjoyable to use so that you can focus on what your app is really great at instead of reinventing new touch interactions. And then look at these touch patterns later if you need some help on how to design your app. We talked a lot about direct manipulation today, the visual feedback, targeting guidelines, and semantic zoom. So then it's time for questions.
Thank you, JK. We'll take a question first from the room. Does anybody have a question? Please can you repeat it so people are having it?
Yep.
Okay.
For semantic zoom, it looks like a pinch takes you up a level of hierarchy, and is it a reverse pinch or a tap that should be used for going down low?
So for semantic zoom, the question is, can you can pinch to zoom out, but what do you do to zoom in? Is it tap or stretch? And it's actually both. So in this case, tap as the primary action is to zoom back in. Semantic zoom is for jumping in content, so we don't expect users to live in that zoomed out view. It's really just a temporary place you go to jump somewhere else. Like I zoom out and I want to go to the beginning and do stuff. So tap is the primary action, but because the whole interaction is reversible, you can actually do a stretch as well. So they basically do the same thing. Yeah.
Cool. So you have a question from Fabio in the Bay Area. He asks, did left-hand users have any feedback about the side and bottom menus? It seems like many of the apps, and also the OS, are usually optimized for right-handed users. And so what's the thought on optimizing for left-hand users as well?
Sure. I still have to repeat if you don't have a mic, I guess.
Yeah, you can. Yeah.
Yes. So the question was left versus right-handed users and what's their feedback on using the system and how much thought have we put into left-handed users. So the interesting thing is when we looked at this and looked at a lot of left-handed users, we actually had a lot of people in the lab. Most left-handed users, they tend to hold their device with their left hand and still use the right hand to interact with the screen, which I don't know if it's good or sad that they kind of get used to having to use their right hand for stuff. But I think about 90% of the left-handed users we had actually used the right hand for the main navigation. So there wasn't really that much of a problem. When we do have, there's more guidance on the MSDN design site on how you should place your controls. We do say left and right for placing controls. And when you hold your device with both hands, which is one of the postures, it's actually whether you're left or right-handed, it doesn't really matter for interacting with the device. Okay.
If you multi-select,
yeah.
Can you singularly deselect, or do you have to unselect all?
So the question is, when you multi-select, how do you deselect stuff, basically?
Can you deselect one thing out of the list, or do you have to hit the unselect all down the list?
So yes. So when you multi-select, yes. So the question is, when you multi-select and you want to deselect, can you deselect one item, or do you have to deselect everything?
Yes.
So once I select one thing here, it's highlighted, but like I said, the interaction is reversible, so I can actually deselect it the same way. So now if I have several things selected, I can use the clear option at the bottom to deselect everything, or I can go back here and say, I don't want to select photos, so I do the same interaction. So it's just the same way you select, you can unselect single items. And then whether you have a clear selection option at the bottom in your app bar, it really depends on your app and whether you think that's a common scenario to want to deselect all. I think in general it's pretty good best practice if you expect a lot of multi-selection, if you want to change your mind. But that's an app decision in the app bar.
Cool, thank you. Another question from email here from Greg in New York. He asks, and this is a bit of a left field question, can you plug two mice into a Windows 8 PC to test multi-touch and have it work like two fingers?
So the question is, can you plug two mice into the system to emulate multi-touch and kind of test out the system? Not as far as I know. That would be pretty cool. What you can do is you can use the simulator tool that comes with Visual Studio, and they do have some help to do touch interactions there. It's not going to be the same as using a real touch device, so that's really the best way to go. Unfortunately, you need to get one, but it's a way different experience.
Any other questions from the room? Okay, I'll go back to Twitter. Martin on Twitter asks, is there an API which can detect which input method is being used for the Metro app?
So the question is there an API to detect what input method is currently used with the Metro app? The way the input stack works is that we have these pointer events that comes into the system. And the pointer events all have properties that tells you where that input came from. So you can look at the pointer event and see, was this a touch event? Was this a mouse event? Or where is this coming from? Was it pen? So you can use that, for example, when we show and hide special UI for mouse versus touch, you would leverage that. So in this case, when the mouse is moved, we know that there's mouse move events coming in, and we show a scroll bar. When I use touch, we know that touch is being used, and then we can hide the scroll bar. So it's the pointer events you want to use for that. And again, if you use our controls, you get a lot of this stuff for free. So we have a semantic zoom control, which you can either use with the list view to automatically have groups be displayed in the zoomed out view, or you can do completely custom stuff. But that will automatically give you the little minus button to zoom out for mouse when you move your cursor. So it's all for free. You don't have to worry about it if you use the common control.
Amy G on email asks, how would you handle tilt/turning of content, such as images, on non-touch devices?
Yes.
Replicating that.
Exactly. That's a good question. I have... yes. So, sorry. So the question is, how do you handle rotation with mouse? And I didn't cover that here. So we have this whole mapping of how you do everything with mouse, touch, and keyboard. And I'm actually working on an article now that will probably publish soon. So I'm not going to show everything here. But one of the things we have here is rotate. And we do have shortcuts for it. So it's a little obscure. Control Shift scroll wheel, which is the standard shortcut used in Win 7 apps today. And for keyboard, it's Control and minus and plus. But if it's a key scenario in your app to rotate, what we recommend is that you actually use a UI command. And depending on how your app is, that might be a little different. But a common pattern would just be to put it in the app bar. If you're in the one app view, like in the Photos app, if this supported rearrange, I would probably just show, rotate. I'll probably just show rotate left and right in the app bar if that's a key scenario.
Thank you. Any final questions from the room? No? Okay.
Cool. Yeah, thank you.